Hello students, we are solving the IB Math AA HL past paper questions and currently we are solving the IB Math AA HL May 2023 paper 1 times on 2 past paper. Today we'll be solving the question number 9 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring classes. So without any further delay, let us start answering question number 9. The maximum mark is 9. It says the following diagram shows the parallelogram OABC with the vector OA equal to A. This is the vector small a, and vector OC equal to C. This one is the small c vector. And the magnitude of the vector C is equal to 2 times the magnitude of the vector A. And magnitude of the vector A is not equal to 0. Obviously, it is not a 0 vector because otherwise you will not be having this side of the parallelogram OA. The angle between the vectors OA and OC is theta. This is the angle where theta is greater than 0 but is less than pi. So, theta is an angle from the first two quadrants. So, it is either an acute angle or an obtuse angle. Point M, this one, is on the line AB or line segment AB such that the vector AM is equal to K times the vector AB. It is a part of the vector AB. So K has to be a fraction. K is a number which is greater than or equal to 0. K can be equal to 0. Means M can coincide with B or M can coincide with A as well. So K can be greater than or equal to 0, is greater than or equal to 0 but is less than or equal to 1. Okay. And OM, the vector OM is perpendicular to the vector MC. This is the OM vector and this is the MC vector. The vector OM is perpendicular to the vector MC. Therefore, the dot product of the vector OM and the vector MC is equal to 0. The subpart A's question is express the vector OM and the vector MC in terms of the vectors A and C. It is containing just 2 marks. So let us start our answer over here. The subpart A. First of all, I am taking the triangle OAM. So in triangle OAM, OA vector plus AM vector is equal to OM vector. Okay. So OA vector, I am writing this. And for the AM vector, I am writing this. K times the AB vector. AB vector is, because it is a parallelogram, I can write the C vector. We can take the C vector for the AB vector is equal to OM. Okay. So I can rewrite this and I can write OM vector is equal to A vector plus K times C vector. Okay. This is the answer for the OM vector expression. And for the MC vector, MB is this way, and I can take since OA is in this direction, OC is in this direction, so I can take this CD in this direction. Okay, so this is vector A because it is a parallelogram, and I need to find the MC vector, and this one is KC. This part is KC, and the full thing is C. So what will this part be? This part has to be equal to 1 minus K. See? Let me show you. If we add these two portions, we should be getting C. So, K is C plus 1 minus K times C. Let us see what is this equal to. I'm expanding this part. Plus C minus KC. So, these two will be getting cancelled and we will be having the C vector, which is the AB. Okay? AB vector. Or else, if you say that how do I come to this, you have just shown the opposite way. You have just proved that this plus this is equal to C, but you did not show how to get to this. Okay. So MB vector should be equal to AB vector minus AM vector. Okay. So MB vector equal to AB is C and AM is KC. If we take C common, it becomes 1 minus K. Okay. So this is how I am coming to this expression for the MB vector. Okay. So now I come to this part. I am taking in triangle. It is MBC. Let me take. So MC vector plus CB vector is equal to MB vector. Okay. Triangle law of vector addition. So MC vector is equal to MB vector minus CB vector. Okay. And so MC vector is equal to MB is 1 minus K times C vector, and CB vector is A. So this is the expression for the MC vector. Subpart B. Hence, use a vector method to show that magnitude of the vector A whole squared times 1 minus 2k times 2 cos theta minus 1 minus 2k is equal to 0. But just by looking at this equation, it is such a weird type of expression. Many students get confused. From where can we come to this type of an equation? Do we have many choices? We do not have many choices. Since this is an equation, we have to start with an equation. And we are having only two equations given. One is this one and the other one is this one. Okay. And we have already used this portion. AM equal to K times AB in order to find the OM vector and the MC vector. So let us now use this one. OM dot MC equal to 0. The dot product or the scalar product of the OM vector and the MC vector is equal to 0 because these two vectors are perpendicular to each other. Okay. So subpart B, OM vector dot MC vector is equal to 0. And now we will be writing the expressions for the OM vector and the MC vector. So it is A plus KC dot 1 minus K C minus A equal to 0. And now I will be expanding. Okay. And this is a vector, this is a vector, and 1 minus K is basically nothing but a number. It is a scalar. Okay. So since I have to multiply these two vectors, we can either do a dot product or we have to do the cross product. But because we are having this dot product, we will be doing the dot product of the vectors A and C. Okay. So this is, I'm writing 1 minus K first, and the dot product of the two vectors A and C, and then the dot product of the vector A with this vector A. So it is minus A dot A, then this with this. So it is plus K times 1 minus K. And now it is the dot product between the two C vectors. And finally, it is minus. Now, this is k, this is the coefficient, it can be written first. And then it is the dot product of c and a. And we know by the property of dot product, we know a dot c is equal to c dot a. Okay. And since I have written a dot c first, even now I want to write the a dot c so that I keep the same sequence, first a and then the c. It is nothing different. Okay. Equal to 0. Okay. And now because it is a dot c over here and a dot c over here, so I can just combine these two terms. So a dot c, and I am having 1 minus k from the first term and minus k from this term. So you see I am having 1 minus 2k and we need 1 minus 2k. Okay. This shows that maybe we are on the right track. Okay. So we are happy. We should be happy. So 1 minus k minus k. And then a dot a. And what is the definition of a dot product or a scalar product? I'm taking the general expression. Okay. A dot b, these two are two vectors. B, we do not have any vector b over here, or I can take c also. We have both the a and the c vectors in this question. So let me take a dot c. So this is equal to the magnitude of the a vector times the magnitude of the c vector times the angle between these two vectors. And the angle between the a vector and the c vector is theta. So it is cos theta. Okay. So this is the expression. So what will be the expression for the dot product between two a vectors? It will be the magnitude of the a vector times the magnitude of the a vector times what is the angle between two a vectors? It is the same vector. So what is the angle between them? Of course, equal to 0. And cos 0 is equal to 1. Okay. Same for you, we have c dot c. So for c dot c also, it is the magnitude of the c vector times the magnitude of the c vector times cos 0, because the angle between them is 0. Okay. And we are seeing that the magnitude of the c vector is equal to 2 times the magnitude of the a vector. Okay. Okay, fine. So we have combined these two for the second term. For the second term, I am writing this is magnitude of the a vector times magnitude of the a vector. So this can be written as minus magnitude of the a vector whole squared. Okay, because cos 0 is 1, I am not writing this portion. Because I have shown this. It is not that I haven't shown it. So I can straight away write a dot a as magnitude of a whole squared. And for the third term, what is it? It is plus k times 1 minus k, and this is magnitude of the c vector times the magnitude of the c vector. And what is the magnitude of the c vector? This is, and cos 0 is of course equal to 1. So this is 2 times the magnitude of the a vector times 2 times the magnitude of the a vector. So 2 times 2 is 4, and this is 4, and this is also magnitude of the a vector whole square equal to 0. Okay. And now I come to this a dot c. A dot c, magnitude of the a vector and magnitude of the c vector. And in place of magnitude of the c vector, I'll be writing 2 times the magnitude of the a vector. Okay. So it is 1 minus 2k. And since we are having 2 times the magnitude of the a vector, I'm writing 2 in front. And it is magnitude of the a vector times the magnitude of the a vector. So it is magnitude of the a vector whole squared. And of course, this time we are having the cos theta part. Minus the magnitude of the a vector whole square plus 4, I can 4k times, okay, let me write 4k and minus 4k square and magnitude of the A vector square is equal to 0. Okay. So now I can take out the magnitude of the A vector whole square because I need this. Over here, we are having this. So I am taking out the magnitude of the A vector whole square because it is present in all the three terms. And I also need the 1 minus 2k, but right now I am not having it. So I can take this from the first term, it is 2 times 1 minus 2k because I have this 1 minus 2k, so I am not multiplying this. You may multiply, so that will be taking more time. Okay, so you have to just see what is needed because the final expression is in front of us. So why should I be multiplying 1 minus 2k with 2? Because I need 1 minus 2k. So let it stay as it is. Okay. Don't multiply the 2 with the 1 minus 2k to get 2 minus 4k. Don't do that. So cos theta, and from the second term, this one, it is minus 1. And from here, it is plus 4k and minus 4k square is equal to 0. Okay. So now I will be combining these three terms because I'm seeing that 2 times cos theta times 1 minus 2k, I am having this part. And this 1 minus 2k when multiplied with 1 minus 2k should be giving us 1 minus 2k whole square. So I'll be combining these two terms, or rather try to combine these two terms to get to 1 minus 2k whole square. Let's see if I can do that. Okay. So I am writing this as the magnitude of the vector A whole squared and 2 and 1 minus 2k cos theta, and there is the minus sign outside, so I am taking the minus sign outside, and it is 1 minus 4k plus 4k square is equal to 0. Okay. So this is 2 1 minus 2k cos theta, and this part is now equal to 1 minus 2k whole square, because 1 square and this is minus 2 times 2k is minus 4k and plus 2k whole square is 4k square. Okay, equal to 0. Now we can take out the 1 minus 2k. It is present in both the terms. So this is magnitude of the vector A whole square times 1 minus 2k and then 2 cos theta from the first term and minus 1 minus 2k equal to 0. Okay. So shown. Okay. So now we come to the subpart C. Find the range of theta such that there are two possible positions of M. Okay. M is over here. AM is K times AB. So if we have two possible values of K, only then we can have two possible positions of M. So we have to find theta values where we will be having two values of K, not a single value of K. Two values of K, not more than two values of K as well. Only two values of K. Okay, fine. And theta is between 0 and pi. That means theta is an angle from the first or the second quadrant. And E is having values from 0 to 1, any value. He is greater than or equal to 0 but is less than or equal to 1. Okay. So I start the answer for this part C over here. Fine. So I'm taking this equation. I'm taking this equation. So magnitude of the vector A whole square and 1 minus 2k and 2 cos theta minus 1 minus 2k is equal to 0. This implies, obviously, magnitude of A is not equal to 0. It is given magnitude of A is not equal to 0. Okay. So either this is equal to 0 or this is equal to 0. Okay. So if 1 minus 2k is equal to 0, we have 2k is equal to 1, implies k is equal to half. Okay. So we should be getting two values of k because am equal to k times ab. We should be getting two values of k in order to have two possible positions for m. But this is giving us only a single value of k, which we cannot take. Okay. They are asking for the theta value. So let us see what is the value of theta corresponding to k equal to half, because we have to reject that value of theta. In case we are including it, we have to reject that part. We have to be careful about it. Okay. So if 1 minus 2k equal to 0, we are getting k equal to half. Okay. Or else what can be equal to 0? This part can be equal to 0. Okay. If 2 cos theta minus 1 minus 2k is equal to 0. This implies that 2 cos theta is equal to 1 minus 2k, or cos theta equal to 1 minus 2k over 2. Okay. And let us see what is the value of theta when k equal to half, which we cannot take. Let us exclude that part first of all. So when k equal to half, cos theta is equal to 1 minus 2 times half over 2. 2 times half is 1. 1 minus 1 is 0. So this is 0. Cos theta equal to 0 implies theta is equal to pi over 2. Okay. So theta cannot be equal to pi over 2. Theta is an angle from either the first quadrant or the second quadrant, and pi over 2 falls in between the first two quadrants. But we cannot take this value of theta because this corresponds to a single value of k. Okay. Let me write. This is a single value of k. This is a single value of k, which we should reject. Okay. So we have to reject theta equal to pi by 2 as well. Okay. Now we are coming to what can be the different values of theta. We have seen what cannot be a value of theta. Now coming to what can be the values of theta. Okay. So we know that k is between 0 and 1. Okay. So since k is between 0 and 1 both included, when k is equal to 0, cos theta is equal to 1 minus 2 times 0 over 2 equal to half. Cos theta equal to half, therefore theta is an angle from the first quadrant. And what is the value? It is theta equal to pi over 3 or 60 degrees. Okay. And when cos theta equal to, when k is equal to 1, cos theta is equal to 1 minus 2 times 1 over 2 equal to 1 minus 2 is negative 1 over 2 implies cos theta is a negative number. That means theta is from the second quadrant. So theta is equal to 2 pi over 3. Okay. Therefore, theta is between pi over 3. This is giving us theta value as pi over 3 and this is giving us theta value as 2 pi over 3. Okay. I hope you were being able to see before also. I'm not sure. Very sorry if you could see. Okay. Theta is between pi over 3 and 2 pi over 3. Theta is not equal to pi over 2. Let me write the answer once more in a nicer way. The answer is in fact the same. And theta is not equal to pi over 2. This is the answer. But I was solving this question with my students in class and we have got this answer and most of my students were satisfied. Only one student, he said he was not satisfied. He said that, okay, theta cannot be equal to pi over 2, I understood. How can you say that we can have the theta values from any value of theta between pi over 3 and 2 pi over 3? How can you say that you will be having multiple values of k for when theta is between pi over 3 and 2 pi over 3, both included? Okay, let me show you. Okay, when you are having, let me take theta value as 2 pi over 3. Okay, so when theta is equal to pi over 3, what do we get? I'm taking this whole equation. I'm changing my pen color so that you understand this is not a part of solving for or answering for part C. This is just to show that the answer that we have given is correct. Okay. So let us take theta value as pi over 3 and we are having this entire equation. So let me write it over here. And this is not equal to 0, so let me not include this part. And 1 minus 2k, it can obviously be equal to 0. And I will be taking this portion as well. 2 cos, in place of theta, I am taking pi over 3. And minus 1 minus 2k. This should be equal to 0 because magnitude of a whole square is definitely not equal to 0. So, what am I getting? It is 1 minus 2k and cos pi over 3 is half. 2 times half is 1. So, it is 1 minus 1 plus 2k equal to 0. So, we are having this as 2k times 1 minus 2k is equal to 0. Okay. So, it is a quadratic equation. So, it is obvious that you will be having two values of k. What are the two values? One will be k equal to 0. If we take this to be equal to 0, we are getting k to be equal to 0. If I take this part to be equal to 0, we are getting k equal to half. Okay. So, we are getting k equal to half when we are taking cos pi, theta equal to pi over 3. So, it is not that we cannot take k value as half. That is what we had found over here. Okay, because we are seeing cos pi over 3 is half, 2 times 1, 2 times half is 1. So, we have written 1 and then I have just expanded. So, it is minus 1 plus 2k and 1 and minus 1, they get cancelled, and we are having 2k times 1 minus 2k equal to 0. So either k is equal to 0 or 1 minus 2k is equal to 0, which is giving us 1 equal to 2k or k equal to half. So k can have a value of half, but if you just take k equal to half from this portion, you will be having a single value of theta. Okay, and it will be corresponding to k equal to half. So you are not having two values of k. For a single value of theta, there should be two values of k. But when theta is equal to pi over 2, k is equal to half. K is equal to half. And we are seeing that k is equal to half even over here. One value of k is indeed equal to half. Okay, but for a single value of theta, in this case it is pi over 3, we are having more than one value of k, and we are having in fact only two values of k, which is needed because there should be two possible positions of m. Okay, so you may take 2 pi by 3 as well. You may take any other value. Pi by 3 is 60, 2 pi by 3 is 120 degrees. Between 60 degrees and 120 degrees, leaving the 90-degree thing, you may take 75 degrees, you may take 105 degrees. Every time you will be seeing that you are having two possible values of k, which is needed for getting two possible positions of m. Okay, so this was all for our today's session. We have completed answering question number 9. Thank you for staying with me till the end. I am Nilanjana Sanyal. I'm an online IB Math EASL and HL level tutor, and I tutor students from both within India and outside India. And I offer both one-on-one and small group online tutoring services to my students. In case you are liking my explanation, please to give this video a like, and please to share this video with your friends so that even they can get benefited by watching this video. And in case you have not subscribed to my YouTube channel, please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. We meet again very soon in our next session. We'll be solving question number 10 of the same paper. Till then, bye.